Well, good evening from Emerald Hill Skies. Good to be able to see you here. I'm going to check and make sure the audio is on. You know, it's been several weeks, hasn't it? Part of it is this crazy sky. I don't know why, but there have been so many nights that, you know, you check the sky app and it just shows it all red and clouded up. Part of it, I think, is maybe if there has been a clear night, maybe I've been out of town that night. But this is the first time that everything's matched and we've been here when it's clear. So we're happy that you're here as well. If you're listening to this recording, thanks. It'd be great if you like content like this, if you go ahead and subscribe. And if you do like it, it doesn't cost anything. If you want to click a thumbs up or click that bell so you'll be notified when we do broadcasts like this. Part of the reason that I don't do a lot of promoting when we're doing a live stream like this after a time of a lull is because I want to make sure that we get everything working again. And I'm always afraid that I'll forget something, you know. But boy, from what I can see, it looks like everything has come up. Let's see, for instance, we've got our scope out there. Let me see if I can get everything sorted out here. You can see our scope. Let's see, where is the scope? Right here. There we go. You can see our scope out there. That's a live view that you can see. For some reason, our roll-off roof stopped right here, and the motor was just grinding against the gears, and maybe there was some ice here along this ledge that hadn't thawed out of that track yet or something. So when I go out there at the end of tonight's observing and I try to retract it and close the roof, I'm wondering if I'm going to have to get a 2x4 or something and go around to the back side. That roof is very heavy, and push while I start the motor. Otherwise, I could be out here for several hours or even be sleeping out there in the observatory. But let's hope I can get the roof to retract. But for right now, I just left it. And I think there's enough clearance, barely, just barely, for the dew shield on the front of the scope to clear the roof, even though it's not fully retracted. Looks like we've got several in the live chat here. We've got Stan from Two Rivers Observatory. Good to see you, Stan. Welcome. And we've also got Wendy. Welcome. We've got about half a dozen. If you haven't already logged on so we can see where you're observing from, it'd be great if you do that. Let's see, our sky looks pretty scary. That's actually a live view of the sky. And if you stop and think about it, there's more headlight, searchlight noise there than anything else. And that's because of this giant moon beam up here that's like at, what is it, 99% tonight. So one of the things about it is, though, in our list, our catalog that we've been working off of, called Cosmic Challenge, it happens we have several targets that we have to catch from the moon itself. So if things work out, we'll just try to catch those tonight. We have about 63 targets left in this huge list called Cosmic Challenge. I think there might be 671 objects in all, and we've got just 63 left to go. So let's dive in and get going. We're using Astro Planner as our observing software, and you can see here, it basically is going to show us a view of all the objects we have left. And they're marked here in yellow. You can see all the ones here in white. Over the past like 23 observing sessions, we've already observed all of these. So now we're down to just this last 61 that are here in yellow. So why don't we start with these objects that are on the moon, and let's see, gonna go to a live view of what's on my screen. So now you're seeing what's on my screen. You can see the sky view down here in the lower right, the scope here in the middle, and then I'm here, hello. Here's Astro Planner, our targeting list, and it also controls the scope. Up here is our mount software. It's It's an iOptron specific software, something or other commander. This is a little control panel that Pete on the Isle of Wight. And Pete, if you watch this recording later with your family or whatever, hello to you and thanks again for that beautiful control panel you gave us that kind of lashes together Sharp Cap, Astroplaner, and Stellarium. Stellarium is right here, and that's kind of our map of the sky. It's our, planetarium software, you could say. And then last but not least, we've got Sharp Cap, which shows us the view through the ASI2600MC Pro camera, which is on the business end of that RASA telescope that's out there in the observatory. It's on top of an iOptron adjustable-height mount, and that's inside this roll-off roof observatory that you see in this view of the scope right here. That's a live view. Look how, almost looks like daylight out there, doesn't it, with the moon. We've got Just the Facts Man here, the colony from down in Texas, north of Dallas. Tiffany, you're here. I didn't know if you'd make it tonight because we didn't give you any advance notice. So Tiffany, there's Wendy. Wendy, there's Tiffany. Hi, and I don't know if we've met before. It's good to meet you. Where are you logging on from, Hein? Okay, so let's get going. Let's go over to our Astroplaner software here. And first it says we're going to go to Bailey. So we're going to click on this, and notice we've already got our scope. We already got Astroplaner talking to our scope. So I think we're ready to just slew to, and we can do that actually just right here, slew to the object. And if you look over to your right, you might see, hopefully, yeah, there you go. You can start to see the scope moving there on the right. And thank goodness it didn't bump against the roof, at least yet. Now on the left, here's our view of the moon. And this is a live view. We're going to drop down to maybe 1/3 of a second at 100 gain. Yeah, there's the moon. And then what we'll do is we'll do a plate solve here. Yeah, too few stars because of all the moon. How about that? So what we might do is go to something close by the moon. Let's go. What I did there is sync with Stellarium. I wonder if turn up the system volume a little bit. Like, for instance, here's Mars. Let's do a quick plate solve to Mars. Is it Control 1? Is that what brings up my little, I forget what brings up my little panel. Is it Control 0? There we go. Oh, we don't have the telescope live in Stellarium. That's sad. Let's try to connect to that. Wonder why directly through it. They've changed something here to a serial port. It won't connect. It says local. I wonder if that's correct. External software or remote computer? Is that what it's supposed to be on? This must have changed. Oh, connecting. Just says connecting, but not connected. So at this point, our planetarium software is not talking to our telescope. They're just not getting along, these two. That opal guy. Tiffany sends hugs to everybody. You're wondering if I watched the Mars occultation. I did not. I'm not much of an occultation guy. Maybe this means it's connected? Connecting, it says. What if we just try it? Let's say Mars, current object, and see if it moves some. Slew. I don't see any movement, do you? So it is not talking to our planetarium software. Huh. Well, that's a bummer because disconnect. Because it's handy, you know, to see what else we got. ASCOM disabled. But ASCOM's not disabled. Must not be compatible with the version of ASCOM. All right, well, we're not going to worry about it then. Bummer, huh? Something about the version is not. Okay, so let's do this. Let's go back to maybe something else that's above the horizon. I know what we can do. No, that's not up yet. Let's just go here. Whatever that is will be fine. It's above the horizon. It's at 39 degrees. Let's just go there. Something that we can do a plate solve. I'm curious. I want to make sure this telescope doesn't get hung up on that roof. That's a very good point, Tiffany. You don't live close to any of those fires, do you? Okay, so there, I think the telescope is settled. So let's go back to sharp cap. Not too many stars there. Let's go back to about 3 seconds. And 400 gain. There we go. Now let's do a plate solve and just make sure we do a tune-up. We were off about 0.8 degrees. Now let's go back to the moon. Okay, slew to object. Now let's look this up. It's object cosmic challenge number 75. 75. And it says it's Bailey, not George Bailey. Up near San Francisco. Yeah, your heart is breaking for those in Southern California. Well, we're glad at least that you're not getting hit by any of this. Man, our heart was going to go out to you, Tiffany. Okay, so that's definitely not the moon. So we're going to plate solve here. $18 degrees. How could it be that far off? That would be horrible. 18 degrees? Seems odd, doesn't it? But let's try it. Okay, it was correct. Who knows why it was off that far? All right, so now we're in the moonshine. That sounds bad, doesn't it? 0.3, 100 gain. Okay, now we need to go down. I always get this mixed up. Let's try this right button here. That's the wrong direction. Let's try left. So what I'm using is these manual buttons. Moon is so bright. Now, if I want to go to the left, I think we want to go down. Nope, up. I was wrong both directions, wasn't I? So up is down. And, okay, but left and right are correct in this case. Up is left. Never mind. Left is up. Okay, let's dim this a little more. 0.1 seconds. And let's zoom in a little. So bright. 0.05 seconds. 10 milliseconds. 3 milliseconds. 0.8 milliseconds. Okay, now we're talking. So this is a 0.millisecond sort of capture of at 100 gain. And now let's find the first object we're supposed to look for. And it is said to be, what's the largest crater on the moon? That's a common question. You would think that whatever the answer is, it would be cut and dry and the crater would be easy to see through binoculars. Unfortunately, neither is true. Not only is that seemingly simple question difficult to answer, the most common answer is anything but easy to see. Look up the question in most references and the answer given is Bailey. A huge impact scar measuring some 190 miles in diameter. That's 9% of the moon's diameter. But, and you knew there was a but coming, it all depends on how you define what a crater is. Many authorities today refer to Bailey as a walled plain, a mini mare, or a lunar basin. By definition, a lunar basin possesses certain key identifying features, including an interior ring of low hills that were created subsequent to the impactor striking the lunar surface. By contrast, a traditional impact crater shows a central mountain peak, which Bailey does not possess. So, is Bailey a large crater or a small impact basin? There's no general consensus. Regardless, its huge girth makes it sound as if it should be easily visible. Not so. That's because Bailey lies near the southwestern limb. So the southwestern limb I think that should be down here somewhere. Let's go ahead and zoom in here. Excuse me. Then there's this thing called libration. The fact that it wobbles east to west, north to south ever so slightly, allows us to see a little over half of the lunar disk, 59% to be exact, although not at once. So first let's find Schiller crater. what I have here somewhere. I thought I had an atlas of the moon. Virtual moon atlas. But it won't launch. So that's not good. So that's evidently not been installed correctly on this newer computer. Oh, it's coming. Just took it a while to open. So how many times did I click on it? I bet it'll open about 5 times. First use setting. Well, let's just close all that. Stu! Oh, Google Moon. That's a good idea, Stu. Stu says there's a lunar lander launching in 2 hours aboard Falcon 9. Going to take 45 days to get there, and landing is Mare Crisium. Well, that's pretty cool. All right. So let's put this over here. You know what else we could do is we could try to search for it. B-A-I-L-L-Y. B-A-I-L-L-Y. There we go. So let's see. Is this help me get oriented here, guys. So on the left is the live view of the moon. This crater is Mare Crisium, which is what Stu said the lander is going to land in. The mission name is Ghost Rider in the Sky. So here's Mare Crisium. That's where that lander is going to land. And then this must be Copernicus, and is this Copernicus here? We're just learning about the moon tonight, aren't we? Look how all of this. I wonder if this is presented correctly. Configuration. I wonder if our latitude, surely our latitude and longitude, use computer date and time, country, does that matter that we're in, Europe, Paris, time zone? That could be a factor, right, or not? No? How do we change the time zone on this thing? United States, time zone, New York, topocentric. Surely the latitude and longitude doesn't matter that much. But they aren't really lined up, are they? This wide set of, it looks like it corresponds to this. It's because my computer's over on its side. So let's figure out how to go up here and turn this thing so it matches the map we have. We need to be able to flip it a little bit, don't we? Flip east-west. Okay, that actually is working for us. Now rotate north-south. That's too much. We need to see how this is that. And then these three are those three. So now let's find Bailey again. B-A-I-L-L-Y. Okay, so on the side where these three are, Bailey is pretty much so this must be Copernicus. That, it looks like if you shoot a line from Copernicus over, you get to Bailey right here. So let's zoom in over there. And here are a bunch of impact areas. Look, there are those three. And then Bailey is the big one that would be in the back paw print of those three. So Bailey is right here. Let's zoom in a little farther. 1, 2, 3. So that's Bailey right there. Boy, it took us long enough to find that, didn't it? 1, 2, 3, and then right there. There's a lot of atmospheric, what they call seeing, disturbance in the atmosphere. Several craters. There's an A, B, F, T, C, D. So not a great view of it. This could be not a great view of it, but we can see it like edge on and see the darkness in the middle of it. It's very interesting, isn't it? What do you guys think? Richard, good to see you. Forget where you're logged on from, Richard. Walter, good to see you. Walter, I forget where you're logged on as well. So Stu says there's Google Moon. Let's go out and find that here real quick. So Google Moon. And how do we zoom it? There you can zoom. So you can zoom in, but I don't see, oh, you could just move it like this. Boy, that's as, they don't give us any kind of, they don't give us any way to zoom out farther. Those rascals, let's see. I can't tell where I am. Besides that, it looks like it keeps repeating. It does. Look, it's the very same crater in the middle of a giant sea, and now watch, I'm going to go to the left. And it repeats again. Okay, so that's not very helpful for me. It'll take somebody smarter than me to run that. All right, so we're going to count that we saw Bailey here. Let's go back to Astro Planner and let's do our observation. So there we're highlighted on it and we say we could barely make out Bailey on the rim, clearly seeing darkness in the middle of the basin crater. Okay, now we're looking for Hesiodus. Hesiodus. So let's go zoom out. It really is a beautiful view of the moon tonight, isn't it? It kind of has a little bit of greenish tinge, doesn't it? I think that might come from our pollution filter, our light pollution filter. Whenever I see this greenish tinge, it makes me think it's actually the light pollution filter on the end of the RASA. I don't know if this picture right here will show us that light pollution filter. No, of course it won't. It's back in behind this camera, so you can't really see it, but it's a green sort of tinge filter, and it's back in behind that camera. That's why I think the moon's a little greenish. All right, let's go back to our atlas and look up Hesiodus. It did not find it, I don't think. Unless that's it. No. Let's make sure we're spelling it correctly. Back to Astro Planner, which is located just behind that. H-A-E-S-I, and it's number 77. Hesiodus. Hesiodus A. Hesiodus. Well, if we'd spell it correctly. All right. Now it's supposedly found it. Where did it find it? Where did it mark it? Hesiodus. Anybody see it here? Oh, here it is. Okay. It's like a needle in a haystack. So the way we're going to find out is we're going to find this big collection of C's here. This is the Mare Nubium. That must be the Mare Humorum right here. So this circle, they call it a C, corresponds with that circle. This C corresponds with that C. And on the edge of that C, right here, is Hesiodus. It's just got a little deposit in the middle. Some of the oddest classes of surface features found on the moon are so-called concentric craters. While craters formed from impacts normally show a well-defined rim and surrounding a sunken floor and accented by a central mountain peak, concentric craters also have an oddly raised inner ring that typically measures about half of the crater's outer diameter. To picture a concentric crater, imagine a donut lying inside a larger bowl. Perhaps the most striking example of a concentric crater is Hesiodus A. Hesiodus A measures 9 miles in diameter and lies just west of the much larger crater Pittatus on the south shore of the Mare Nubium. Ah, I see. So Hesiodus is this little one here, that. And this bigger one is Pittatus, as in potato, not really, Pittatus. The best opportunity to observe Hesiodus is unusual. Come on the nights after first quarter. If the timing is right, watch the sunrise over Hesiodus A. As sunlight falls along the smooth wall of the crater's bowl, the rays will strike the inner ring and cast a shadow along the opposite wall that can momentarily make the ring look as though it's floating. Okay, so that's when the light shines across this crater and illuminates that crater. But tonight we have Hesiodus here. Not a lot of contrast, but definitely seeing the circle here beside Pittatus, P-I-T-A, like a pita bread, Pittatus, Hesiodus. So this is 9 miles for perspective. We're looking at something that's just 9 miles in diameter. So if you've ever wondered when you look at the moon, what does 9 miles look like on the moon? Well, that's 9 miles. Pretty fun, huh? Okay, so back over to here, we're going to do make sure our highlight is on Hesiodus, and it is. And we could say, we loved being able to see a 9-mile crater for perspective on the moon's size. I mean, it's not really that great. Not really that big, is it? Could see Hesiodus with Pittatus next door. How fascinating is that? Tiffany says, very cool, Doug. Walter says, Arkansas. Richard, northeast, so northeast Illinois. Northeast Illinois. Chicago, basically. Tiffany says, wow, that is fun, isn't it? Don't you just love the way the moon dances around with all the atmospheric disturbance? It's because we're zoomed in at 200% of our optical viewfinder. Like 100% is right there. Okay, so now we're ready for Lambert R Ghost Crater. So let's go to our moon atlas and look up Lambert R. There it says Lambert RR. Is that it? That's as far as it zooms. Yes, that's Lambert. I don't understand why it's calling it a ghost crater. Oh, that's Lambert Crater. So what is Lambert R? Let's find out. So we're going to go back to Astro Planner, and it should be object 78. Man, it's a mystery. Lambert R. The moon is haunted, not by ghosts and goblins and ghouls, but by ghost craters. These craters, which probably formed during the initial period of heavy cratering some 4 billion years ago, were later washed over by the rising tide of lava that subsequently formed the Maria. Today, all we see of these first-generation craters are ghostly silhouettes of their uppermost rims protruding out from the surrounding flat lava plain. What lies below remains a mystery, entombed forever in lava. Oh. A haunting example of a ghost crater can be found nearly centered in the Mare Imbrium, the Sea of Rains. As the Terminator moves slowly across the Mare Imbrium, watch them 36 hours after first quarter for sunlight to shine on the crater Lambert. Named for the 18th century German mathematician Johann Heinrich Lambert, this crater measures 18 miles across, bringing into range of nearly all amateur telescopes. Close scrutiny reveals a spidery ejecta blanket surrounding the crater, indicating that its formation was sometime after the Mares. Okay, let's see if we can find this. So, you see how you've got this giant 3-part deal here. Well, that's this giant 3-part deal here. And this thing corresponds to that thing, which is Copernicus. That, I suppose. We think. And then over here, let's see. Is this stuff. That would be this, but we are looking for where is Lambert again? I've lost it. It's the lost Lambert. Oh, here. So these are 3 tiny pock marks. We think this is this, and that is that. So halfway between these so would it be that? This. So this must be this ghost thing. Lambert R. Ah, there just barely is a rim there, isn't there? So if that corresponds to that, which is Antarctus. See how bright that is? See how bright Antarctus is there? That must be Antarctus. And that's Copernicus, and that's see that peninsula sticking out here? That's that peninsula. And this whole big rim. See this little carved out thing here? That's these. The sinus iridium. And that hole there, that must be that hole there. So I'm not going to lie, this crater here, Lambert crater, must be around here. It's just not got much relief, you might call it, does it? It's not got very much three-dimensional. Yes, Tiffany says Lambert R is really tough to see. You're right, because there's not much relief with the direction of the light coming in. Look over here in this view of the moon. See how the light is entering from this left side more. But see, that is a full moon, isn't it? But man, the light is entering from the left side, and it's giving these a lot of relief. See how this opposite side of Lambert is lit up and the left side is dark? Well, in our case, we're not seeing any relief like that, are we? But this is that, apparently. So if you cross over like this, you're crossing over like this. If you cross here, it makes this triangle. So this is that triangle. There's that triangle. Lambert is closer to this edge of this side of the triangle, but a little bit indented, and about halfway so about right here. If you kind of use your imagination, that's Lambert. And then this ghost must be right here, Lambert R. Hard to see. You know, if we were a real student of the moon, which we're not, we would come back when this light was shining from the side rather than square on. So let's make sure that this is highlighted in AstroPlanner, and it is. And let's say we think we saw we think we barely made out the rim, but there wasn't much relief or three-dimensional character to the rim's shadows. So all we could see was a kind of hint of the rim of Lambert R. But remember, in our Cosmic Challenge book, that's really all Harrington promises. He says, a shadow of its former self, a ring that's larger than Lambert, and the R stands for ruin, Lambert ruin. Just does not stand out. It's like, let's say, what if this white patch here Just imagine, what if that white patch is Lambert? Then maybe this might be Lambert R. Maybe. So if that's Lambert, maybe this is Lambert R. But we don't see as much relief. But you can kind of see, here's something, and then there's a darker echo of it. That's all we're talking. Okay, now let's go to, let me check you guys. Hard to see any detail with nearly full moon. 16 days old would be better. Yeah, Walter says 15 days. Just looked it up. Stan says bump up your exposure a little. So 0.9 milliseconds. A little brighter. That did help. Well done, Stan. So here's that triangle. There's the triangle. Man, it's just going to be the ghost of Lambert. Yeah, we would have to come back and see this later in the month if we were a real student of the moon. Okay, on to Messier and Messier 8. I'm sorry, Messier and Messier A. So that should be 82. 82. These are let's go back to our Messier. Oh my goodness. That's too many crater names. Oh, right here it is. So here, this kind of like triangular with Mar Nubium, Mar Insularum, and Mar Imbrium bridges into Sea of Serenity, Mar Serenitatis, the Sea of Tranquility, Mar Tranquillitatis, and then we don't go down here, we go over here. Got a little better definition here. Just trying to keep straight which direction is which. So this Mar Crisium is this. This is Mar Fecunditatis. And Langrenus is right here. And this is that crater, which is Tarantius. So if you shoot between Tarantius and Langrenus, and look over to the left where Gosinius is, you make a triangle between these three craters. And then over here, there are two craters close and two craters here and then two craters close. how there are rays shooting out from that. So that's right here. So the one right here farther is Messier, and then Messier A is this one. So Messier A has rays shooting out from it. So this is Messier, and that's Messier A. The double craters Messier and Messier A have a story to tell. Named for the French comet hunter Messier, these craters are separated from one another by less than 4 miles. Both are nearly the same diameter and noticeably oval. Messier spans 5 miles by 7 miles, while Messier A is a little larger, 7 miles by 8 miles across. In addition to their similar appearance, both craters also share a common origin. A billion or so years ago, a meteoroid slammed into Mare Fecunditatis. The meteoroid itself was not necessarily special. What was unique, however, was the narrow angle at which it struck the surface. Tests conducted by Don Galt of NASA's Ames Research Center and John Wedekind of Caltech in 1978 suggest the impact was probably less than 5 degrees. The initial impact created the crater Messier, the western member of the duet. But then, just as a flat stone skips when it strikes a pond at a narrow angle, the meteoroid fractured. A large fragment skipped and was propelled another 4 miles downrange until it struck the surface to create Messier A. An ejecta field from the second impact threw twin rays of bright material further downrange. This unique pair of rays, looking almost like twin comet tails, immediately calls attention to the two craters. The twin parallel rays extend westward some 90 miles, nearly to the edge of the Mare. Well, right there it is. I mean, we have solid sight on this, don't we? See that 90 miles of trail of ejecta material. That's pretty fun, huh? Is it just me, or is it bulging and wriggling and moving? Making me queasy to see, Stu says. Yeah, it's the seeing, the atmospheric disturbance, Stu, for sure. Or if you're Canadian, Messier, eh? Yeah, that's right. Messier. Okay, so let's make sure that's marked in Astro Planner, and it is. This was our clearest observation tonight. We could clearly make out Messier and Messier A with the 90 miles of ejecta. Fascinating. All right, now let's look for Schroeder's Valley. Not the flashbacks. No. Let's look for Schroeder's Valley. So we're going to go over here. It's SCHRO. SCHRO Valley. Well, I didn't find it. Let's just look for Schroeder's. There, Schroeder. Schroeder. Okay, so it's pretty much centered in that big triangle at its base. And it's almost like a shallow crater right down from Copernicus. Excuse me. Okay, so here are the three. Oh, right there it is, look. Right? Maybe this. That would be Schroeder's. And what number is that? 84. Schroeder's Valley. As the terminator sweeps across the smooth surface of Oceanus Procellarum during the waxing gibbous phases, it passes over an area of jumbled terrain that looks like a cluster of islands in otherwise tranquil ocean. The most obvious reference point in the vicinity is the extraordinarily bright crater Aristarchus. Which is Aristarchus? Oh yeah, we saw Aristarchus a while ago and it was indeed bright. But that's on the other side. This is Schroeder's down here. Yeah, there's Aristarchus. And here is Schroeder's. Schroeder right here. Huh. Herodotus' tail. I wonder if there's more than one thing named Schroeder. Aristarchus. Herodotus. Schroeder's Valley. Valley Schroeder. Okay, we're about to call the wrong thing because the other one was called Schroeder something too. This is called Vallis Schroeteri. Vallis Schroeteri. Okay, so this would be over here and in here. Right along here. All those formations. Jumbled terrain like a cluster of islands, otherwise tranquil ocean. Aristarchus appears far more modest than its dazzling neighbor, but it has something that Aristarchus doesn't. It has a tail. The tail curls away to Herodotus' north. Twisting around toward the east as it flows through the mountainous terrain on its way toward the ocean's coastline. You know, you kind of use your imagination, you can make out the tiniest little tail here. And it's kind of echoed by these islands. It's like a little rift. And that rift valley is what's called Schroeder's Valley. But I'm not sure that a first-time viewer through our RASA would see that. It's just because of getting used to the way the RASA sees. Here's that little tail. And then, like I say, it's echoed by these islands here. We had a hard time with this at first. It helped to locate it with Aristarchus. We barely saw the Rift Valley that is Schroeder's. Dean, good to see you. Long time, thanks to my third shift job that I'm retiring from in a month. Well, congratulations to that, Dean. But that has been a long time coming. You can flip your view in Sharp Cap, Stan says. Yes, we've done that before, you're right. I guess it's all the same if you flip the atlas. Conservative Sue 13 says, hi, thank you for your channel. Well, thank you for taking part with us tonight, Conservative Sue 13. Good to have you aboard. Okay, so we're ready for the Serpentine Ridge, 85. Whatever that is. The Serpentine Ridge. Let's try Serpentine nothing. Says it's a wrinkle that parallels the eastern shore of the Mare Sinitatis. Wow, 310 miles. Dorsa Smirnov and Dorsa Lister. Dorsa Smirnov. Aha. Yeah, look at that. And Dorsa Aldrovandi. Dorsa Lister. Aha. Okay, so this is that 3 thing. Then you go into, so there's the 3. Then this is Serenity. Okay, these are very hard to find. Look at how this little curvy line here would remind one of a continental shelf of a sea. And look at this. This is on the map, and this is the real-time observation. Now you come out and see where this first traces along, and then you see it parting here. So there's this would be the Dorsa Lister, and this would be the Dorsa Smirnov. But these would not have stood out to us without the definition from the book, would they? This continental shelf is a little more likely to stand out to us. The change in colorations as you get out here away from the edge. But then this funny little, I guess it's almost like a topographic hill that's real long, wouldn't have stood out to us, and didn't. But now that we know to look for it, we can find it. So we're going to say, once we knew to look for this, we could find it. Conservative Stu, likewise, thank you to Emerald Skies. Very kind of you, Conservative Stu. Dean says, the Luna is big and bright tonight, that's for sure. Stu says, I agree, Stu, and I don't express my appreciation enough for this opportunity. Thank you, Stu, for the encouraging words. Dean, saw you at the Global Star Party. Now Emerald Hill Skies. Doug, it's a great night. Stu, try increasing your exposure by half a millisecond. Half a millisecond. .4 milliseconds. Yeah, that works too. I'm not sure we see this formation any better, but it is brighter. And I bet it's especially brighter on the YouTube channel because maybe there's a little bit of degradation going into the YouTube channel. Okay, so thanks for that. Stu says, can always put it back if it's worse. Yep. It's pretty bright. That's up to you guys. You guys tell me if it's too bright. All right, now let's go to Plato's Alpine Rills. So here we go, Plato's Alpine Rills. Plato's Alpine Plato's Alpine Plato Alpine Rills. All we see is Plato, and that's of course that big crater. This would be number 124. A real student of the moon would watch these over several nights and see them develop with more relief, you know, more of that three-dimensional light. Alpine Valley Rill. Alpine Valley Rill. Alpine Valley. Alpine. A gash in the lunar Alps. Valles Alpes. Valles Alpes. Valles Alpes. Oh yeah, right there. Oh my, that's very stark, isn't it? This right here. It's like a sword cut through the topography there. So it's over on the left side, exiting the left side of these three things. So the left side right here. That sharp, jagged crack. See how that looks unnatural? Looks like a straight, jagged crack. Would show up a little better at different times of the month when the light fell along that crack, so you could see it a little more contrasting to its side topography. So this is 124. Okay, Armstrong, Aldrin, and Collins. Armstrong, Aldrin, and Collins. 125. Stu says, I'll be here for that if you are, Doug. Maybe coming back and seeing the contrast. So these are 3 craters in a row near Tranquility Base. Armstrong, Collins, and Aldrin. Armstrong. Why are these not jumping out at me? Collins. So here, here, and here. So we're going to go across the 3. We're going to go into, go down, across the 3, down, and then down into Tranquility. There they are, Armstrong, Aldrin, and Collins. Armstrong, Aldrin, Collins. Armstrong, Aldrin, and Collins. Boy, those are beautiful. I mean, they don't look like they're outlandishly large, do they? The names of the 3 Apollo 11 astronauts are now permanently commemorated on the surface of the moon by a trio of small craters that lie near the mission's landing site along the southwestern shore of the Tranquility Sea. Since the largest, named for mission commander and first man on the moon, Neil Armstrong, only measures 3 miles across. However, high magnification and steady seeing is needed to see them. So they're in order: Armstrong, Collins, and Aldrin. Armstrong, Collins, and Aldrin. If you go on the side with 2 other craters, that's the Aldrin side. So here are the 2 craters. So this is Aldrin. Armstrong, Collins, and Aldrin. That's fun. I don't know if you've seen the, is it Apple TV version For All Mankind? It's not good, if you ask me, because it intentionally rewrites history as a kind of a element of fiction for the sake of imagining what something would have happened if we weren't the first to the moon from the United States. But I don't like the way it just rewrites things, but mixes it in with true history, making maybe our younger generation confused. Did we really get to the moon first? Not that it's that important. Armstrong, Aldrin, and Collins were super visible tonight. All right, let me see what you guys are saying. Conservative Sue 13 said something about @DB. Stu said the Aldrin crater, also known as Buzzhole. You guys are funny. Okay, we're ready for Hortensius. Hortensius. Wonder what's special about it. Number 126. I can't see anything. Thanks to the lunar samples brought back by Armstrong, Aldrin, Collins, and other Apollo astronauts, it is well established the vast majority of craters are impact craters, formed when leftover debris from the formation of the solar system slammed into the moon. But if we look carefully, scattered among all those impact scars is direct evidence that the early moon was also a hotbed of volcanic activity. Excuse me. The Hortensius dome field. Five or six bumps in the otherwise flat plane. A dome field near Hortensius. That's as far as we can. Is it this? 3 little domes. Yeah, most are clustered together in small groups. Lunar domes. It's lava that flooded the giant impact basins to form the Maria we see today. Had a low viscosity. It flowed quickly due to its high temperatures. The lunar core cooled over time. However, the emerging lava decreased in flow rate as well as temperature, which increases viscosity. Hortensius. 5 or 6 bumps. Okay, so let's find this. We're right pretty much in the middle of this threesome here. Wow, look at these bridges here. Well, I guess we can see a crater here, and this corresponds to that. So are you guys thinking it's one of these? Hortensius. Hortensius. Four in a row. See, look at those 4 craters in a row here. And then several domes away from Hortensius. So that would be the 4th crater in the series. that bright crater is here. That is that, which is Kepler. So here's Kepler. And Hortensius is just outside the line between Kepler and Copernicus. So here's the bright guy, Aristarchus. There's Kepler, and there's Copernicus, and Hortensius is right. Aha, so here we have it. Hortensius is the bright one. And there are bumps, supposedly. So here are 4 craters. This one corresponds to that one. 2, 3, 4. 1, 2, 3, 4, and then the bumps go on a little bit forked off to the right. I would say those bumps are not real obvious to us under this lighting tonight. Tiny little bumps here. 1, 2, 3, 4. They curl off this direction. It's more of a, we can see where the bubbles are, but we can't really see them. We could make out the 4 craters with Hortensius on the end, but these surface bumps, but we could only see the slightest hint of any surface bumps. Yes, the dark patches on the moon, the mares, are all lava fields, right, Stu? Okay, let's see if we can get Plato's craterlets. Plato's craterlets, 128. Plato. So let's go here and say Plato. So where this large 3C thing is here, it's the very clear so this, right? No, this. Yeah. So that's Plato. One of the great challenges facing even the most devoted lunar observers is trying to see the many small craters that dot the lava-covered floor of the walled plain Plato. Plato itself is a prominent impact scar measuring 62 miles across. It takes no more than 10 by whatever binoculars to see Plato after the sun rises in the sky 1 day after first quarter. Unlike typical impact craters, Plato shows no sign of a central peak or chaotic floor. Instead, it appears perfectly smooth and at first bluish, or at first blush, featureless. That's because shortly after the blast that excavated the bowl of Plato, lava welled up to flood its interior, hiding any central remnants of the original impact. So, craterlet designation. Well, I don't know if you can see, this is Plato, but look at the way they blow up the floor of Plato and show us these numbered little impactlets where they're very small craters. I don't think the light permits us to see any of those floor craters of Plato tonight. Looks like these would best be viewed on days 8 and 21 of the lunar phase. We're in day 1, let's say. So we need to wait 8 days to see these. Just going to say we could clearly make out Plato, but to see these craterlets on the floor, we would need to come back this season around 2 or 3 a.m. for a proper view of what's in that crater. Fascinating, huh? Nothing that we can see, though, whatsoever. Okay, that completes, hallelujah, that completes all of the moon objects that we were lacking. And now we're down to the last three, I think, galaxy clusters. That one is at -1 and 2, barely above the horizon. This one is at 9 degrees altitude. Let's just see if by chance we can catch this one. Able 1060, which is object 134. It is a very bright moon, but let's just see with the filter and with EAA, see if by chance we can pull it in. The Able Galaxy Cluster 1060. Just 8 degrees above the horizon. Let's go slew over there now. Look at how our slew doesn't show up. I guess because it's judging we're too close to the horizon. So what we're going to do here is switch to, we're going to switch here to Emerald Hills Low Horizon. And that let our slew show up. So we kind of cheat a little bit. We're cheating our our horizon that we've shot and trying to go below it. So let's say goodbye to the moon. And we'll also zoom back out and switch our time back to 3 seconds. Keep an eye on our scope, make sure we're not crunching against that roof that didn't retract all the way. And let's do a default next target, and the name is Able 1060. It has settled. Doug, you'll have to do a skylet on the craterlets. That's good, Tiffany. Dean, you can see them well when the Plato is at the terminator, I bet. Hein, Tiffany and Shih Tzu, was the skylet on the crater? What was skylet on the craterlets? She's talking about, well, I'll let her tell you, Hein. Bunch of little tiny craterlets inside, yeah. Right, short broadcast called skylets, you're right. Typically it's a close-up of like one particular feature or one particular part of the craft. Looks like you're taking long exposure images a bit of 8. Well, I missed that. That's the wrong camera. Let's stop this live stack. Are we in the wrong? No, we're in the right. We've got the wrong camera here. Look. Okay. So that's funny. We were using the 178 on the moon, I guess, all that time. Is that right? That seems odd, but it worked great. I mean, it was awesome, but that's odd. If indeed we were using the, I don't think that's possible. I think it just must be a change here. Okay, so let's try this again now. Sequencer, default, next target cycle. Okay, now it seems to be working okay. Okay, we're in our last 15 minutes here, but we'll just see if we can get to this cluster. And it's very low in the horizon, so it's not going to be a pretty picture of it, but it will show us a little bit different view than what we've been looking at through the moon. Of course, so the moon with 99%, something dim like this cluster, these are at magnitude, 13, 14, even 16. We're not going to have a perfect night to see all these objects. Resume or clear the stack. Let's clear. Yeah, that's right. Now we'll do very strange. Very strange tonight, I guess because of the moon, you think? Let's look at our, yeah, I'll take a look at the, you can already tell the sky cam. Let's go ahead and close out this moon. We don't need him anymore. So see, we're aimed right in the middle of all this brightness here, this halo. This is the building that we're sitting in right now, by the way. And I'm in this corner room where there's just a little bit of light. That's my truck. That's real time. And here's the roll-off roof edge of the roof of the observatory. You can see all the snow. We have a lot of snow in the, just the road is the only thing that's clear here. And all that snow is reflecting as well. But man, 20 seconds at 100. Very strange, isn't it? Do you think that's because of the brightness of the moon? And maybe because it's so low on the horizon too. We must be just barely shooting up over the edge of that building. Or maybe we're looking through that tree. Let's take a look at our stellarium. And we'll say stellarium sync. Yeah, so it does show us above our horizon, but it's low enough that it is kind of being bothered by that horizon and also by the moon. Go back to our live view and we'll go here to tools and say plate solve, solve only. And then we'll say deep sky image annotation. Okay. So it's showing this galaxy cluster. For instance, NGC 3285. 3285 is right here. But odd, isn't it, that look how narrow our light peak is. Again, I think because of the moon. Lots of Park is 5/1979, so we're spot on. But these galaxy clusters are not showing up, I think because of the 100% moonlight. Well, it's 12:20, so we've almost gone 2 hours. With the moon at 100%, let's come back to this as our next object in our sequence. Tiffany says, Doug, I'm hoping you're going to be able to get the roof back on. That's a great question. Rec has a question. I saw Mars with the moon last night underneath it, and then a couple of hours later, Mars was ahead of it. Wouldn't the moon outrun the further planet from Earth's perspective? Yeah, and the visibility, the motion isn't that visible. So throughout a whole night, it would just be barely visible. Let's go look at Mars real quick. I think without stellarium talking to the scope, the easiest way to do that would be to go to this. Let's first save this. And let's go to this thing that we call wish list, and we'll add Here we'll disconnect. And here we'll add Mars. I keep T Corona Borealis, waiting for that to go nova, you know. We're going to add Mars and slew to Mars. I'm watching the scope to make sure it's not going to get caught on the roof. No problems. Okay, let's stop our live stacking here and turn off our deep sky image annotation and switch this back to 3 seconds and this to 400. And then let's do plate solving. So there's Mars, you see in the center. Now let's zoom in and cut back to about 1 second or 0.5 seconds or 0.2 seconds. Switch this down to 100. So with the RASA, that's all we get with Mars. We just get the fact that it does resolve to a disk. Now let's go over to Stellarium and see Mars. So the moon is here. And let's turn on our degree thing here. Angle measure. From the moon to Mars is just 14 degrees difference. So, you know, in a one night, that 14 degrees might change to 12 degrees or something. It's not going to move that much. So probably we're just talking about perspective. That was different. Let's move our time forward a little bit faster than normal. So now it's 12:40 a.m. There's 1 a.m. and there's still 14 degrees apart. There's, speed up a little more. There's 2 a.m. Okay, let's stop it right there. 16 degrees. So they've moved 2 degrees different by 3 a.m. And we'll run it to about, whoop, 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 whoop. I got a little carried away there, didn't I? Woo, that went by fast. Let's go back to the 15th at 7, 8. 15th. Oh, 15th. So really, we're like 1 a.m. on the 15th, aren't we? Here in Louisville. Sorry. So there's there's 6:30 a.m. and they're 17 degrees apart. So you don't get that much apparent difference in one night, actually. I don't think so. Yeah, Heinz says, good question though, Reckham. All right, well, it's 12:27. That takes us to the end. Once again, we've been working on this, this book, Cosmic Challenge, and it's by Philip Harrington, and it consists of about 671 objects, and when we started the night, I believe we were at 61 to go, 63 I mean to go, and it looks like we're at 53 to go. So we've covered about 10 objects tonight on the moon, and we'll keep up next time. This has been our 24th session, working our way through the 656 objects of Cosmic Challenge. Kind of a longer list compared to, like, say, compared to the Messier list, which is 110 or so objects. This is about 6 times the length of the Messier list. So it's a rather extensive list and very challenging. Has challenging objects for 15 to 18-inch scopes, which we're trying to do with our RASA 11 using EAA. And so far, I think we're kind of hitting them okay with EAA, the way it is. So I hope you'll tune back in. If you aren't subscribed, just hit that subscribe button if you want. And if you like, you could also hit the bell to be notified of content like this. You could also hit the thumbs up, and that would get things up in the algorithms of other viewers who are searching for astronomy-related stuff on YouTube. As always, we want to say thanks to you for staying, if you stayed and watched all the way to the end. We also should say thanks to God for making the moon and all the cool things we get to look at through this telescope. What I might do that might be kind of fun, as kind of a bonus, I might leave the stream running and put it on the scope cam. Let's see if I get to the scope cam this way. Put it on the scope cam and then go out there and try to close that roof. And then I'll actually come back in and stop the live stream after that. So the mic will drop. Tiffany, thanks for that. You're very kind to say thanks for a great session. And you're the one that makes it a great session. You guys that are here with us. Don't feel like you have to stay, but I'll go ahead and leave it running, and I'll figure out how can I get that roof closed. It'll look kind of precarious. I don't know if I can turn on the mic out there. Oh yeah. That might, if I'm lucky, see, desktop. That might let you hear the roof trying to close. So I might be able to talk to you through the mic on the scope cam, which is a WISE 4. So I think I'll go ahead and mute this mute this mic that I have on, because it'll just rattle and distort once I get outside. Okay, so I'm going to go ahead and say goodnight if you want to sign off, but I'm going to try to close that roof outside. Not sure how I'm going to do this. I'm going to take the remote control in my hand. I'm going to walk around outside. I'm going to use something to try to push it closed. A lot of snow on the ground. Not sure how this is going to work. So thanks for being with us tonight, and we'll catch you next time. Here I go, muting the mic on the inside. Okay, I'm not sure if you can hear me or not. You might be able to hear me through the security camera. I didn't take the scope back to its home position, and I probably should have done that, huh? So I think I'm just going to turn off the mount, kind of do this the brute force way. Okay, so use that, and then here's that. Now let's lower this. We can hear the motor at first didn't like how cold it was. It's about 11 degrees now. And that's just the pure temperature of 11. That's not what they call the feels like temperature, with maybe a little bit of a breeze. Not a lot of wind tonight. The trees over there are pretty still. But boy, just since I've got my glove off, I mean, I could have been using this with gloves. This hand controller is designed to lower the scope with your gloves on. But just that short amount of time with no gloves on, I can already feel my fingers starting to protest, saying, "We are going to crack open on you, Doug." Okay, so there's our adjustable height pier is down. Now, I think we're ready to take the scope. Let's see. Over to about there. Oh, you can hear that. There it went off. I think we're ready to try to close this now. I think first I'm going to go outside and just visibly look up in the roll-off roof and see what I can see that might be blocking it. I do have a ladder here, so that's good. I could actually get on the ladder outside. That would give me some leverage. First, I'm just going to look up in here. Where it's tough to see. I don't see anything different about it. What if the track, which is made out of nylon, what if the track is so cold that it sort of broke off some teeth? That's a possibility, huh? Doesn't look like it has. Okay, so I think I'm going to take the ladder outside with the remote. I'm going to stand up and then actuate the remote and push on the roof from the ladder. Okay, wish us luck here. Out of
it's all the ice that's on top of the roof. So I'm going to have to try to clear off some of that ice first, and hope that by getting off that weight that'll help. So I'm going to put the remote control back here so I don't lose it, and then I guess I'll use this broom, or maybe the broom, and then the de-icer for my truck. So I'm going to use this de-icer from my truck to try to get some of the ice off the roof. sure enough, giant sheets of ice on the roof. Giant. So I got 2 more panels to clear off. Okay. Okay, I cleared off 3 of the sides. Let's put the cover on the stove. big ice plate. Boy, my gloves are not made for winter. Now we're going to try this. Hopefully we haven't ruined the track. I'm going to get back here and push on it. Still won't go. Wow. What a shame, right? It's because the middle panel still has ice on it, I think. But I don't think I can reach the middle. Rats. So, what now? I guess I could, because there's so much, you see there's so much weight from that ice. I'm going to have to try to clear the ice off the middle panel. Wow. Too much ice. I'm going to show you. This is one big ice chunk. One giant ice chunk from the roof. I did have some warmer gloves in my car, so I went and got those. Still chipping ice off the roof. Okay. I now have all the ice cleared and going to try it again. Done. It's on. Woohoo! All right. We got to put the lens cap on the scope. And the small lens cap on the 178 camera. Okay. Start the dehumidifier. Okay, I'm going to go close the stream. If you stayed to the end, thanks for watching with me. See you next time.